The next presentation, we had to make a small switch, and now we have demystifying AR hardware from NVIDIA's evolution to real-world costs and capabilities. And the presenter is Markus Warg, Sales Manager at Amber AI and Data Science Solutions. We'll look at approximate cost for both NVIDIA-branded systems and OEM servers built with NVIDIA chips, providing a clear sense of investment scales. And yep, stage is yours.
Thank you. So hopefully that's a benefit that we switched the slots from Terry to me this time. Thank you for being able to talk to you. Oh, yes, the clicker. So quickly about myself, I'm 20 plus years in the industry. I've been dealing mostly with infrastructure, lots of storage experience, 10 plus years, and I've been in AI land for the last 1.5 years, more or less. And I'm going to talk to you about AI hardware today because, as boring as it may sound, it's not. It's very relevant, and many of you probably know that already, but it's more relevant than ever. And you'll see why, and I brought a few samples here, and I hope that you will have a good and also entertaining, but also very a teaching talk about how things work in AI land. Did I bring an agenda? I did, but you'll see it anyway, as it happens organically. When you think about hardware in terms of NVIDIA GPUs, it's not that easy to buy those things. There's very strict processes that are being prescribed and described by NVIDIA how you have to buy certain solutions. You can't just buy them randomly online. Some of it, yes, consumer things, yeah, but the more enterprise type of products you need certified partners for. And Amber is a partner that has had the NVIDIA Elite Partner status for already 9 years. That's quite something, because people are trying to get these competencies these days. And our history goes back 19 years, and before 2010, one of our founders was already working with Jensen personally on building custom workstations. So that's just something about Amber, and we have all the highest competencies by NVIDIA. So if you want to buy super large clusters, so-called SuperPODs, we are one of 3, I think, in Europe who can do that for you. Now, a big thing is hardware. Yeah, we do resell hard and software. That sounds mundane, but the ecosystem is much bigger. There's always a customer, and they talk to us about more things than just give me a quote for that hardware or give me a quote for that software. So the ecosystem is like this. It's always about hardware, NVIDIA hardware, OEM hardware, Supermicro, Gigabyte, whatever, lots of storage vendors, many more logos that we are in partnership with. They don't fit on the slide here, but storage and network is also a part of that all the time. You heard it before, AI factories are not only the GPU, not only the engine, but the whole car needs to make sense to go somewhere. You know, most people are getting distracted by looking at the engine only. Infrastructure, where do I put my hardware? Previously, that wasn't a big issue. I put it in the basement, I put it in my data center, end of story, more or less. With very energy-hungry systems that have come up recently, like in an exponential, manic way, I should say, in a positive way, the question is much more often, where do I put these things? How do I cool them? How do I get the energy to that? And so the topic of infrastructure is very imminent, and there are very flexible approaches that we also take care of. We facilitate those for the end customers, and it's part of the bigger story. Software, very important as well. You need proper software to make the most out of your very expensive, let's say, investments. So you don't want to have any of these valuable GPUs run idle at any time. So there's different ways. We can also help you facilitate that. Also, the software cannot be bought just so. You need to follow certain rules and processes. Also, if you are part of a discount program at NVIDIA, for example, Education, Inception, or Connect, you need a certain partner level to work with to activate that discount for you. So it's also one of the things that we do. And in terms of use cases, we work lots with consultancies like Deloitte, but also others, EDAC, a manufacturing independent company out of Germany having 9,000 people. So they work in the field with their end customers, and whenever they detect a need for, oh, yeah, someone wants to implement AI, they take care of the use case and what's the before and after, what's the ROI, etc. And then when it comes to, hey, we need to source hard and software for that, we need to find a place where to run it, then they often include us. So it's a multi-dimensional approach that someone like Amber deals with. Development of AI, it's a long story. People started 1964 to do research. Gonna go quick here, 2012, AlexNet, next big step. The major step that everyone of you is aware of is 2022, the ChatGPT moment. That's where the massive breakthrough came, and now there's no end. Jensen calls it a $100 trillion opportunity. He probably would say, in the meantime, it's much higher than that. Also, the laws of scale. I'm pretty sure that nearly everyone of you is familiar with Moore's law, where the approximate thing is that every 2 years the number of transistors on an integrated circuit will double, and it's always been like that, more or less. And Jensen, therefore it's Wang's law, he introduced a new law, and he said, okay, that has changed, because it's not only reduced to one dimension of hardware or silicon capabilities, but the outcome of AI, in this case specifically it's inferencing, is going exponential. So you don't need to wait for doubling every 2 years, but it's much faster. There's lots to say about it. I won't. I just want to say this is the blue one is a representation. It's a linear chart. That's why, even though the transistors for Moore's law, they doubled here, but the scale is so small, that's why you can't really see it. Now the question is, why is everyone so obsessed with hardware? I'm pretty sure you're on LinkedIn and you read news, and every day you will read news about new data centers, gigafactories, megafactories, whatever. Nordics, America, nuclear power plants, small ones, power issues, billions of investment left and right. And why is everyone talking about it? Why is that? And you have phones that use GPUs already that are purpose-built for your phone. If you do speech recognition, you do use ChatGPT, whether it's paid or free, doesn't matter. You might have used AI for video upscaling or for creating generative videos. Some of you might know about autonomous driving or drones, or doing certain things with 11 labs, synthesizing speech, etc. All of these things always physically need GPUs somewhere, either on your local device or in your local data center or in the cloud. Doesn't matter, but the calculation doesn't grow on trees. That's why there's such a strong demand for hardware. And it needs to be satisfied, but also it needs to be understood that not all hardware is equal. And what I brought you here today is one example of an NVIDIA RTX Pro 6000 Blackwell GPU. So it's quite the latest one. It's a real one. It's quite heavy. You can come to the front and touch it or lift it up if you want. And this is a GPU that you can put in a workstation. And you can put multiple of those in a workstation. And the thing is, that particular GPU is capable of many things. It has different types of cores doing different types of activities. And you all have probably heard CUDA cores and CUDA, the software library, and that in 2010 it was partially open sourced upon pressure from the academic environment. And those are more like, you can see GPU, general purpose GPUs. So cores that can do parallel processing. In itself, quite simple, but you basically cannot have enough of it. Tensor cores are more specifically for AI, for matrix operations. The floating points and the precision levels, they have different pros and cons. And if you do certain things with Chromax, SGEM, DGEM, whatever, you might look at double precision FP64. But these days, the new standard is basically in the Blackwell architecture, floating point 4, which is a very efficient, focused way of building those cores so that the outcome per activity, per time, per use of energy is very good. And by many factors through this, the AI workloads have been sped up. And then another type of cores, the so-called RT cores, ray tracing cores, they are designed for graphics, so that gaming is something that everyone's familiar, at least from knowing about. Maybe not everyone's a gamer, and ray tracing accelerators. So if you see very realistic graphics that move fast without any stumbling or whatever, and the proper shadowing, that's what these ray tracing cores take care of. And a card like this has all three of those cores. That means it's a multi-purpose card that can help you with normal parallel computing, with AI calculations, inferencing, but also with visualization. So many people in the industrial world who wear Apple glasses and they do virtual representation of factories, they will use cards like that. And we will go into more detail later. So across a condensed view of the hardware spectrum, you can think about it in terms of T-shirt sizes. Yeah. One issue that has, in the last 10 to 15 years, corporate IT departments, they have tried to standardize IT solutions so that you could internally buy a solution and you get cross-charged for it. It was there to make things standardized, therefore maintainable, therefore secure, and also economic. In the last 3 years, AI and everything attached to it has evolved so fast that no larger corporation has standardized anything. What would they standardize? You can't say, this is AI. This is a much too big of a statement. And that's why it is difficult to say, this machine can do that. It always, the Americans would say, your mileage varies. But we can try to put certain categories into certain amounts of spending. So for example, if you, the prices I will discuss later exactly, but I want to show the spectrum from small to huge. What's the difference? What you can typically use those things for, and how much flexibility is there when you use those things. And there's one thing there's a division here. To the left, you see all those systems up until here, they are air-cooled. The golden system, a DGX system, which I brought you a bezel of from a real one. It feels quite solid, so if you want to touch it, it's nice. Many people who install those systems for the first time, they install the system in the data center and they take this to the office, and there goes your LinkedIn, your proud LinkedIn post. Yeah, these systems are available air-cooled. We've heard this multiple times yesterday and today. The new trend is liquid-cooled because it's much more efficient and it's required for getting out producing the heat dissipation from the new density, etc. And the DGX and HGX systems, we'll discuss details later, more details later. It can be both ways. You can have it, the DGX not, but the HGX, same power, can be air-cooled as well as liquid-cooled. And then the big racks to the right, they will only come liquid-cooled. There's no way you can cool that stuff with air. The small systems, they range from your desktop to the IT room, so you can use it at home or in your whatever office. If you go this way, you need a proper IT, a 19-inch rack. Some people have rooms like this where one of those racks is there, and maybe it fits there. Maybe the cooling is not good enough, but you can start with proper data center deployment from here up until monstrous gigafactories, which is basically beyond most people's imagination. So what I want to do next is I want to go and look at all these components, what you can do with it. You may have seen it the last days. This thing is finally shipping. It's called an NVIDIA DGX Spark. So it's a mini representation of this big thing on your desk. It's basically at the size of a Mac Mini. Many people have been waiting for it. And it's, if you're an AI developer that wants to be independent, autonomous, if you're just an enthusiast, and if you want to test everything in the most concise way on your desk, this is it. You need around 4,000 euros, and you can do with this thing pixel and AI workloads. That means it has CUDA cores, ray tracing cores, and tensor cores. So you can even load models up to 200-something billion parameters. But that doesn't mean it's very fast if you want to serve 10 people. It's not going to be the case. It's just for typically one person to interact with a fully autonomous stack of latest technology, but it's not a server that is meant for serving lots of people. But it's a very, very good way to do independent development work. The next step would be one of these RTX Pro 6000 Blackwell workstations. You could fit up to 2 GPUs in there. Your price may range from 12 to 20,000 if you use these cards. But of course, there are also other cards, 5,000, 4,500, 4,000 and smaller, that can all fit in. That would be much cheaper then. But I'm using the top model of the RTX series because that's what everyone's after at the moment. One of these cards has now the Blackwell architecture, and it has 96 gigabytes of VRAM. So you can imagine if you do these things, if you're familiar with it, you can do quite a lot with one of those cards. And you could fit 2 of them in one of these workstations, and you could basically put them under your desk or into the broom room besides your office. And there's literally no limit in terms of what you can do. All kinds of things. Those are general categories, of course. But when I say rendering an Omniverse, that's the graphical side. Omniverse is an NVIDIA ecosystem, a platform that allows you to represent reality in digital world. So it's called digital twins, digital metaverse, industrial metaverse. So every representation of something like a building plant, etc., that you do in the virtual world will somehow be involved with NVIDIA Omniverse. And that means it needs those ray tracing cores to display them. You can literally put DisplayPort and HDMI cables into there. And the rest is if you want to do some inferencing for your private rack for 50 people at a certain modest performance with a certain accuracy, etc., then you can do that, but it's not, if you're a larger company, it's not your server to give you, for thousands of users, a big inferencing machine. You can do some small training workloads and all kinds of things. So that's sold a lot because it's one of these entry-level machines to get going, because it allows you to do everything, and it allows you to learn while you have compact cost. Yeah, so that's one of the things that sells a lot every week. The next thing would be a so-called RTX Pro 6000 server. It's even in the meantime standardized by NVIDIA as a 2-way or 8-way machine, but if you deviate from the standard, which in the end doesn't alter the functionality, you can also have any combination of GPUs in there. In this case, it would be fitted with up to 8 of those RTX cards. And what you need to know, those 8 RTX cards, they cannot be combined to form a bigger GPU. They are all individual for each other. So you need to have a software process that talks to multiple RTX cards in parallel, and the parallelization needs to come from the software layer. There's no hardware talking to each other. There is, but it's very slow because you need to go from the card into the main board, PCIe bus, through memory, RAM, and then into the next card, and that is, compared to what's going on in the CPU, very slow, and therefore multi-GPU spanning workloads are ideally not done on an RTX card. But yeah, you see, you can even nearly spend 100K on a box like this, and it's a very, very multi-faceted workhorse. You can do lots of things with it, also very fast. You can serve quite a bunch of people internally with certain workloads if that is what you're looking for. Again, the full breadth of things that you can do. And I underlined the server. So this card is the Blackwell 6000 Pro, and it has an active cooler. So it's powered by the power supply, and it cools itself. And this one is passively cooled because it relies on sitting in an IT rack where there's typically front-to-back cooling, so that it's most efficient. And this one will always use 600 or 700 watts of power, and these can be done. You can have them in 600 or 300, depending on. By the way, it's a fun fact. The difference between the 600-watt RTX card and the 300-watt RTX card is only a difference of 15% of performance. So think about that. One step further, now we're changing the GPUs in the same server. Looks the same on purpose, but the GPUs, they also look a little bit the same, but they are now H200 NVL cards. H200, if you know, NVIDIA describes everything in terms of product names like Volta, Ampere, Hopper, Blackwell, Rubin, and so on, if you're familiar with that, but that's where the acronyms come from. So this is a Hopper 200 card, which has no RT cores. You cannot do any visualization with it, no graphical workload. And those cards can be 2- or 4-way linked with so-called NVIDIA Link cards. NVLink is a protocol that NVIDIA, a standard that they invented and defined, so you can connect 2 or 4 cards into one entity. That means the connection, the communication between the GPUs can happen via that bridge, which is much faster than through the main board. It's still is nowhere as fast as inside the GPU. So whatever you can do in one GPU, you should be doing there. But it's at least a major step forward, and that's how you can connect your GPUs into proper, powerful servers there. So you start at 50K, end up at 230K. Depends on the overall, config of the server. Some people need more internal storage and bigger CPUs and others don't. But that's somewhat the range. And the use cases have condensed down. It's primarily LLM inferencing. Of course, you can also do training with it. You can do proper RAG and serve quite a number of people internally with a machine like this. And since this machine is any OEM, the flexibility is all yours. So if you have a certain network setup that requires a particular configuration, you can influence that. So and now we're leaving the OEM world and quickly going to the NVIDIA DGX world. So whenever you see a DGX, it's an NVIDIA native product. And I always say this is the Bugatti. You can only buy it in one configuration, fully spec'd. You can't change RAM or the NVMe, or you can't change the network cards because you don't need as many. You buy this the way it is. And that's why it's the most standardized turnkey solution that you can buy. And there's lots of benefits in conjunction with the software of NVIDIA. Of course, they do optimize their hardware and software for each other. And the best performance that you get out of the same hardware is if you combine NVIDIA products, soft and hard. And here, we look at so-called systems that have 8 GPUs on a board, and they cannot be separate. You cannot have it as 4 GPU configuration or 2. It's 8 only. You only can have multiple of these boxes. And so it's 400,000 or 500,000 euros if you, depending on if you're part of a discount program or not, and it also depends on how many years of service you're going to buy. That's where but if you roughly think about 500,000, then you're pretty much on spot. And those prices are quite stable. Same for the cards. Pricing has always been more or less stable for the last years. So this machine can be obtained from NVIDIA, and if you get the same internals from an OEM like Supermicro, then it's called HGX, B200 or B300. But then you don't get the DGX software, the optimized libraries. You need to take care of that yourself with your own Ubuntu, whatever. And it's widely used for proper AI training, inferencing of all sorts, scientific research, and universities, research educations, research entities, they use those a lot. You can cluster them. You can have 16, 32, whatever, and then there are certain specifications, base pod, superpod, etc. It's a huge field, yeah. And in B200 you have 181 gigabyte of VRAM per GPU times 8, and the B300 has 288 gigabyte of RAM per GPU. And that's quite significant because then you end up 8 GPUs, 2.3 terabytes of VRAM. You can load big models and do lots of good stuff with it. And last but not least, the very, very big ones, the rack, fully rack configured only solutions, they go by the name GB200 or GB300. That stands for Grace Blackwell. Grace is the CPU. It's an ARM-based CPU. It has a name Grace. The next generation will be called Vera. It will probably, I don't know, VR something, some number will be the next one. So and Blackwell is the architecture for the GPUs. So those are combined. You have 2 GPUs and one CPU, and they access the same memory directly. That means the ways of communication inside the system are very short. You don't need to go through any bus or any other system, but you have the fastest way of exchanging data with the system memory and the VRAM. So that's also the most energy efficient in terms of energy per output. Of course, one rack requires 130 kilowatts of power. The next generations that will probably be announced sometime next year at the GTC, but you've already heard about it in the media. They will be hundreds of kilowatts, up to 600 per rack. Telling you, if you know anything about power, that is an insanely dense amount of power demand for a very short surface. So you can think about, and if you read all these news out there, how many data centers are being planned, it looks nice, but someone also needs to plan how to bring all that energy along to feed those things. It's not easy. But that's a problem I can't help. Yeah? I mean, someone else will take care of that. But what I know is that the output per energy, in this case, is just exponential. So yes, critics might say, oh, AI stuff uses lots of energy. True, but that's a philosophical, completely different question, whether we should have an eye to advance the humanity or not. But if we use it, this is the best way, because you get much more out of it, despite high density of power requirement per rack. So if you know anyone who does large model training, like massive foundational training, or serving as inferencing systems for large amounts of people, then this will, one way or the other, be underneath it. And you see the price, plus minus 7 million, one rack. And if you see pictures online where they show you data centers that have dozens of those, you can do your own math. It's always, that's where the billions come from. And it's quite insane in a good sense, but that's where everything is heading. Right, so that's my overview of AI hardware, to give you a little glimpse of small to large, what people are struggling with, why is it difficult to choose, and sizing those things is not straightforward. It's not like sizing a Microsoft Exchange database like it was in the past. It's always very custom, and some of you in the room have done these things. They've put a lot of mind to it. What do you need for what? And it also goes along with a lot of testing. And then you make your own experiences, and you derive your own things. But nevertheless, NVIDIA publishes a bunch of benchmarks, but you need to know they always think in 8 GPU terms. They hardly publish sizing that is small GPUs. They give you, they make it a standard to use 8 GPUs, and you may not have the initial funds to use 8 GPUs, so you need to interpolate that downwards yourself. Okay, that's the last default slide, why you choose Ember, because we have lots of experience. We help you to do the holistic picture. We have a very good relationship and network with NVIDIA. That means if you have a particular request, you need a contact or whatever, we can most likely find that for you in a short time. We have very, very long experience, and customers like to talk to us about not just the quote for this server or that software license, but about the whole thing. And if we cannot help you with something, we'll tell you, but we will most likely find a partner and bring it in, which will fix your request. Any questions?
Yes, is there any questions?
If not, Andreas. Yeah, there's a mic coming.
Thanks a lot to the very insightful presentation. I really like GPUs. So my question is, when is the next generation of GPUs coming into play, and to which multiple is it faster than a Blackwell Ultra, from your perspective?
Yeah, that's the thing, from my perspective. So the current architecture is called Blackwell B200 or Blackwell Ultra B300. And the next architecture will be called Rubin. That's already, it's not a secret anymore, and there will also be Rubin Ultra. I don't know whether it's R400 then, it's just speculation. I also don't know that is the general announcement of the architecture. Most likely, cards like this, given past experience, will most likely be available. My guess is end of next year. That's when you actually can start consume them. Whatever the next bigger systems are, let's call them, for the sake of it, R400, also experience would show a year from now. Because right now, the B300 is starting shipping. and it was announced properly at GTC in spring. If you think the same is going to happen next year, then it's more or less a year from now that you can have some kind of access to the latest generations. I have no particular numbers in terms of multiples of how much faster a certain card will be or how much VRAM it'll incorporate, but knowing the massive curve that we saw in the past, you can assume it's going to be significant again.
Back here, what are waiting times for the hardware that you have? I mean, I guess you cannot just go into your store and take the B300 home with you, right? If you want something, is it even guaranteed that you get it at all, right? There's always these reports about capacity and so on, but even if, do you have to wait for months for this stuff, for years? I don't know.
Under normal circumstances, when there's no disrupted supply chain event, natural catastrophe, whatever, some storm. Under normal circumstances, it's quite known what you can expect. So, giving you an example, right now, if you order a B200, a DGX, 6 weeks, a B300, 10-ish, yeah, can be plus minus something, or 10 to 12. Yeah, it depends. There are certain options that we sometimes have, we sometimes don't have to accelerate things. That depends on how close you are to certain people at a certain time. But generally, that's the span of time that you need to factor in. Since the supply chain is so tightly regulated, we can make very reliable statements about whether this is going to be in that range or whether there will be disruptions. It's not just some hearsay, because we need to register those things with NVIDIA. They formulate an offer to the distribution. The distribution gives it to us, and that is all very, very strict. And therefore, you know exactly whom to ask. And so, should there be a disruption, it would be known. But those are the times that you can calculate with. With the cards, it's much easier. Some distribution vendors have them on stock. Not too many, yeah? No one has 5,000 of those cards on stock because of the price. But a certain bunch of 50 or hundreds might be just incoming at a distribution center. And then if you order it in that moment, you get it within 2 weeks. But it's safe to say that any cards, including some, it needs to be incoming first, is 4 to 8 weeks, not worse than that. Sometimes so this is the cash cow, the RTX 6000. So they focus on it. 5,000, 4,000, 4,500. They are much less requested. So those are currently for. I think the 4,000 is currently end of November or beginning of December, because there's much less interest. So they don't prioritize it as much. So it's in the detail, but the things that everyone is typically looking for, it's quite reliable.
Thank you.
You're welcome.
Hi, sorry, I missed the beginning of your talk, but I was just wondering if you think NVIDIA stocks are still a good investment looking into 2026?
Can you repeat that? I didn't get.
I was wondering if you think the NVIDIA stocks are still a good investment looking into 2026?
No stock advice from here. I don't know. I cannot have a public opinion about this. I would say it's safe to assume that overall the topic will grow in the next years, whatever that means. There's a representative of AMD in the room. We had nice chats last night. He might have his own opinion about it. So but I think overall, the whole industry won't go backwards. But you know, anything can happen on the way. If you get a quote from us, we will tell you, to the best of our knowledge today, the delivery will be X amount of weeks. Yeah.
Hi, thanks for your talk. Couple of questions. Is your territory exclusively Austria?
No, we actually operate worldwide. Of course, we have certain organic focus. Thomas and Aisha, who are also in the room, we primarily focus on the DACH/Europe region. We also do operate globally with certain projects. And the good thing is with NVIDIA, you are not bound as a reseller to countries. I know in classical IT land, when you're a storage reseller, you are a storage reseller for Switzerland and not for Germany. But here, you're free.
But if you look at Austria, because now we're here in Austria, how do you see the demand actually for like purchasing dedicated AI hardware that is going to be deployed on premise?
So anything we sell is always on premise. That's I should say that. The demand in Austria is increasing. There's more and more. I mean, overall, the clarity increases about use cases and what people want to do. There was a time, the last years, of lots of proof of concepts and pilots where there was testing going back and forth. Nobody really knew what to do. That's getting better, and there's more clarity in what do we want. And there's a few people in the front here that are from Austria, and they do their own things. You might want to chat to them. I can introduce you. But we see increasing interest, especially this year, since summer. There's an increasing amount of requests with specific ideas in mind, and that's the point, specific. Not just, I'm interested in this AI thing. We heard that a lot, but that doesn't mean someone is actually doing something. But specific means, we want to do this. Can you help us? And that's a good thing, because it means people are intentional about what they do, and they don't just play around, which is also important. You need to get up to speed to learn your things, but from a business economic perspective, it's good if people have clarity. I'm doing this because of proper goals.
I would have a question, because in the past we've seen a lot that the trend was getting rid of your own hardware and moving to hyperscalers and rent basically the compute. When would you say that it makes sense now to go the other direction and say specifically for GPU hardware to move, to not rent from a hyperscaler, but make your own hardware available in your data centers?
That's one of the main things that people think about these days. Is everything going backwards? And partially, absolutely yes. But our customers, they tell me the following. Yes, we have a top-level cloud-first initiative or strategy, but my crown jewels of data that I actually put a lot of money towards to really do research, no, they will not be in the cloud for multiple reasons, but also for reasons of I want full autonomy of the systems to control them the way I want. My stack, no noisy neighbor. I have full visibility and control. And that's another reason. And another reason is, yes, the cloud is very good if you want to do a few things every now and then, run a few jobs, a few hours. It can be overseen properly. That's no problem. But the moment you have bigger jobs running in a more permanent fashion, the cloud cost will not be a good calculation very quickly. Yeah? So this thing, a DGX B200 with those 8 GPUs, let's stick with the price of 500,000. If you rent the equivalent of those B200 8 GPUs in one of those hyperscalers, even more expensive, but the GPU clouds, 40K a month. You do the math, how quick? Of course, plus your own power and stuff, but the turning point for this thing, when you buy it and you run it yourself, to be in your favor is not far out. And then you have full autonomy. In the cloud, when the money is spent, it's gone. If this thing, let's say one day this thing becomes old and it's just third generation in your company, it's still yours, and you can still do some basic research or have your students work on it. And in a cloud environment, money is gone, access is gone. So that's what most customers do. That's why they put it on site. They even bring back data from the cloud for the purpose of crunching it with proper AI hardware on premise. I know it seems counterintuitive because we worked completely the opposite way the last 20 years or 15 years, but that's happening.
Thank you.
Thank you so much. Is there any more questions? Then applause for Markus.
Thank you. We're outside at the booth. You can touch those things if you want.
Yeah.
Lift them up. Happy to talk to you.
Yeah. Now we have a lunch break till 2 p.m. So see you next time.